Next we'll be doing with multiplication of matrices. So for multiplication of matrices, there's a special condition. What's the condition means? We are having two matrices here, x and y. So if you want to multiply x, y, right? X, y means x into y. If you want to do means, what has to be the condition is the number of columns in the first matrix, it has to be equal to the number of rows in the second matrix. So if the first matrix here, if you check, it has two columns, right? Two columns. It has to be equal to the number of rows in the second matrix. In the second matrix, you check, here also there are two rows, right? So it's 2 and 2, right? So the multiplication of the two matrices is possible, okay? And to find the order, what we have to do means, if you check, the order of the first matrix is 2 by 2 and the second one is 2 by 1, right? So the order of the final matrix, how it will be found means, whatever is there in the middle, right, it should be removed. So the final order would be 2 by 1, okay, because this 2 both are common, right? So the final matrix, it will be having the order, the first number by the second number, last number. So 2 by 1, this is the final matrix order. Now we'll be doing the multiplication of two matrices, okay? So the first matrix, there are two persons, A and B, and A bought 10 pens and 11 books, okay? B bought 12 pens and 8 books. Okay, we want to find the total cost each spent. Okay, so the cost of one pen is 10 rupees, whereas the cost of one book is 20 rupees. Okay, so we want to find out what's the final cost, the final money that A had to pay and final money that B had to pay, right? So for that we have to do the multiplication of the matrices. So write down the first matrix, 10, 11, 12, 8. Now write down the second matrix, 10 and 20. So for multiplication, how you have to proceed means, the first row of the first matrix you have to multiply with the first column of the second matrix to get the first element, right? So this row with this row. So if you check, 10 times 10, first element with first element, 10 times 10. Now you have to add the second one, 11, the second element in the first row, times the second element in the first column of the second matrix, 11 times 20. Okay, this is the first element of the final matrix. Now what you have to do means, there is only one column here, right? So there's no second element here, okay? Second element would be down only. So now you have to do with the second row and first column. So second row, first element is 12, first column is 10, plus second element is 8, times second element is 20, right? Now we have to just multiply to get the final, add the answers together, okay? 10 times 10 is 100, okay, this is 100, and 11 times 20, it is 220. Then 12 times 10 is 120. Now we have to add this also, right? Then 8 times 20, it's 160. Now we have to just add these two. 100 plus 220 would be 320, and 120 plus 160 would be 280. So this is the final cost of the products bought by the two persons, A and B. A had to pay 320 rupees, whereas B had to pay 280 rupees. Next we are going to discuss about one properties of multiplication. Actually, multiplication of two matrices, it's not commutative, because in numbers, when we multiply any two numbers in any order, we'll get the same answer. But in matrices, it's not necessary that we should get the same answer. Sometimes we may get, but it is not always the case. Okay, so if we take this example, we have two matrices A and another matrix B, then we have to prove that AB is not equal to BA. So now let's first do AB. Okay, for AB, what you have to do means write the matrices together. Okay, close together. As we check, AB is possible, right? Because if you check, the number of columns is 3 in the first matrix and the number of rows is 3 in the second matrix. So both are same, so we can do the multiplication of the matrices, right? So now if you do the multiplication, the first row with the first column, okay, there is only one row and one column, so we'll get only one final answer. So do the multiplication. 1 times 3 would be 3, plus 2 times 2 would be 4, 3 times 1 would be 3. So the final answer for this one, AB, is 10, which is a 1 by 1 matrix. Okay, only one element is there, so it's a 1 by 1 matrix, because first one's row number is 1 and the second matrix column number is 1. So it is a 1 by 1 matrix. Now we have to check if BA is the same or not, right? So now writing B first, 3, 2, 1, then writing A second, 1, 2, 3. Now we have to do first row with first column, okay, multiplication. So 3 times 1, okay, there are no elements, right? So that's it, you cannot do any further. Then first row with second column of the second matrix, 3 times 2 would be 6. First row with the third column, 3 times 3 would be 9. Now doing the second column, second row of the first matrix, right? So 2 with each elements, 2 times 1 would be 2, 2 times 2 would be 4, and 2 times 3 would be 6. Then third row with the first, second and third column, okay? 1 times 1 is 1, 1 times 2 is 2, and 1 times 3 is 3. So finally we are getting a 3 by 3 matrix. Why we got a 3 by 3 matrix? If you check the first matrix, it is a 3 by 1 matrix, whereas the second matrix, it's a 1 by 3, 1 row 3 columns. This is 3 rows 1 column. So if you check, 1 is same, that's why we were able to do the multiplication, and the final order would be the first row number 3 by the last column number 3. So 3 by 3 matrix. So if you check both the answers, AB, we are getting a 1 by 1 matrix, whereas BA, we are getting a 3 by 3 matrix. So both are totally different, right? So that's why AB, it's not equal BA always. Some cases maybe they are same, but usually they are not equal. Next we will be doing one question to prove an important property of multiplication. So here we are having two non-zero matrices, right? Now they have told us to find the product AB. To do this, first write A, then write B, and do the multiplication. So first row with first column, right? So 0 times 3 would be 0, plus minus 1 times 0 would be 0. Okay, then next, first row with the second column, 0 times 5 would be 0, plus minus 1 times 0 would be 0. Then now second row with the first column, 0 times 3 is 0, plus 2 times 0 would be 0. And finally second row with the second column, 0 times 5 would be 0, and adding it with 2 times 0, it is also 0. So if you check the final matrix, it has all the elements as 0. So this is a 0 matrix. Okay, 0 matrix. What is a 0 matrix? If it has all the elements as 0, it is known as 0 matrix. So in normal multiplication, when we multiply two numbers, we will get 0 only if one or both the numbers are 0, right? But in matrix, it's not like that. As you see, both are not 0 matrices, right? Because if it has some elements as 0, it is not a 0 matrix. It should have all elements as 0 to be a 0 matrix, right? So if you check here, both are not 0 matrix, but when we are getting the final answer, we are getting it as a 0 matrix. That is, it's not necessary for two matrices to be 0 matrix to get the final answer as 0 matrix. So next we'll be doing with the properties of multiplication of matrices. So the first property is associativity. So associativity, how it works means when we are having three matrices A, B and C, right? Then when you are multiplying A, B first and then multiplying it with the third matrix C, it will also be equal to, when you are getting the multiplication BC, then you are multiplying A times the product of BC. It will be equal. That is the associativity of matrix multiplication. Next we will be doing with distributivity. That's the second property. So distributivity, it's just opening of brackets. It's just simple. A times B plus C, you are doing B plus C first and then multiplying A, right? So it will also be equal to AB plus AC. How it comes means just open the bracket, right? A times B plus A times C will get the result. Same here also. First A times C, then plus B times C. So it would be AC plus BC. Same thing. Okay, for distributive, just you have to open the bracket. Finally, we are having multiplicative identity. Okay, multiplicative identity is the identity matrix. So what is identity matrix? Identity matrix is a square matrix and it is also a diagonal matrix. If you check all the diagonal elements, it will be having it as 1 only. All the non-diagonal elements, it would be 0. So what is the diagonal? This is the diagonal, right? So the diagonal would be all 1 and rest of the elements, it would be 0. So if you multiply any matrix with the identity matrix, you will get the same matrix. Like any number, if you multiply any number A times 1, you will be getting it as A, right? Same number. So this identity matrix has the same function as the number 1. So when you multiply any matrix with the identity matrix, you will get the same matrix. That is the multiplicative identity.